Hello visual effects people, I'm AK and this is Fluid Ninja Live 1.5 and finally Ninja is unleashed. We are not anymore bound to the local simulation space, but we could move in infinite world space and all containers are properly responding to this. Quickly one more example from the world space level. In this case, I've attached a volume container and a flame ball to the character, but as you could see, it is moving properly together. Wherever I move, there are no bounds. So, I'm switching to the changelog available at the project homepage. And so, this is the main feature, the world space offset. And we are briefly going to talk about 3 other minor updates. There is a dedicated chapter in the manual, chapter 28, moving in world space. Please have a look, all assets and the related parameters described. Returning to Unreal Editor, and this level, I'm sorry, I meant this one. So, as you could see, this large plane of water is like an infinite field, and we have objects, and we have the pole moving in this infinite field. And so I would like to make a quick breakdown to see how it works. Well, our regular experience with Ninja, that we have a fixed location container with fixed bounds, and as soon as we leave the container, there's no more fluid effect. Well, what happens if I attach the character to the container? I'm going to do this using a simple set actor location. I'm tracking the pawn and I'm binding the fluid simulation container to the pawn. Well, this looks awful because there is no relative movement between the pawn and the simulation container, so there is nothing to track in terms of relative motion. What can we do? Well, the new feature located at the preset manager in the fields section, here, all fields offset by sim area motion. The name is quite telling, and as you could see, we are offsetting, we are moving the simulation itself according to the world space motion of the character. Which means, wherever I move, the simulation container is following me, but the fluid is properly lagging behind. I could leave behind these fluid marks. Now, using the buffer visualization, I'm switching to the pressure buffer, and as you can see, it's like a height field. Red is positive values and blue is negative values. And I could use this as an elevation map to drive, let's say, the normal map or the vert position offset of vertices. So, by stamping this pressure buffer to the water surface, I could bring this local container with myself. But it's a very small container, so I would like to resize it a little bit. I'm selecting the Ninja Live actor, going to the details panel and multiply the size 3 times. One important thing, yeah, I'm just switching on this feature. Right. So I would like to notice that the field offset value needs to be manually tweaked because it depends on the container size and the sim resolution. The previous value was 0.9 and this time I'm using 0.3 because the container became 3 times bigger. It could be automatized, but this is an experimental feature, so take care and try to adjust this parameter. And I'm switching back to the pressure buffer and going for a splash. as you could see, the simulation container, which I'm taking with myself, is big enough to cover the large part of the visible area. And so it could be even bigger. It's a good solution to have like a full screen fluid simulation. And if you search the blueprints, you will find all the updated functions with the tag live 1.5. So that's the thing. We have like a detail map applied, which is imitating this surface foam. But that is just a small technical nuance. I would like to move on to the level which officially explains this whole situation, and that is tutorial level 4. It is an update version of the classic word space level. So again, just to emphasize it, on the left you could see the traditional locally fixed Ninja experience. This blue orb is moving in the fixed container, and on the right you could see that the orb and the container moving together, and using this field offset we are having a proper illusion of movement. Just to take another example, switch on the palm possession, approaching this guy. So, as you could see, again we have an attached container, and with the field offset the fluid is properly lagging behind. Here's another example. In this case I've been using a volumetric smoke container which has a thickness, so it's not two-dimensional but real volumetric 3D. How does it work? Well, we have a pawn, and the pawn has an embedded Ninja Live component, and we have a separate volume smoke container, and the volume smoke container is attached to the pawn. So the pawn and the embedded Ninja Live component is generating the simulation and the offset, and volume smoke is just attached to the same position as following the pawn and is receiving the output from the Ninja simulation. And we have a similar thing here, this volumetric smoke container following the pawn. I'm zooming out a little bit to have a look at this. And this flame ball is also following the pawn. So it's like two separate simulations, one for the flame ball and one for this field of smoke. And both offsetted in word space. So much about this new feature. Now I would like to explain a little bit about an existing feature, which is, by having a look at the preset manager panel, is located at the same place. So we had a new feature here, all fields offset, and here velocity field influenced by sim area motion, which means we are not offsetting all fields but modifying only the velocity field. What's the difference? Well, I would say it's mass conserving, which means we are not losing any density at the edges of the simulation. As you could see, I could move containers around and it is bouncing inside the simulation space. So it could be used for a different purpose, and it's a legacy feature, but we're still keeping it because in some cases it might be good. Yeah, why not? I could illustrate that with an example. So here's this guy that we have seen before, and as you could see, that the smoke is on a weird way is creeping behind it. How is it happening? Well, the thing is the following. First, I'm selecting this character, And then, yeah. Having a look at the settings, yes, the velocity field offset is like 0.8, which is fine, but also we have a non-zero value at the velocity field offset. What if I set it to 0? Well, if I set it to 0, the smoke is properly left behind, so it's not following the character, but it remains at the place where it has been emitted. So, if I provide a negative value to this field, it means the word offset is trying to keep the smoke at place, but the velocity offset is pushing it towards the character, so the smoke is like creeping behind the character and it's like trying to follow it. So in my opinion, the combination of velocity field influence and all fields offsetted could provide nice results, and you could experiment with all these settings. Shortly, that's the thing I wanted to introduce about the world space offset. And returning to the manual, well, let's say returning to the changelog, what is this second thing? Write output material. Yeah, to demonstrate this, I'm leaving level 4, updated level 4, and moving to updated level 30, which is volume smoke. Volume smoke default level. I switch off pawn possession and visiting a newly placed container. It is called stage 5C. Right. What is happening here? Well, I remove the volumetric smoke container. Let's say I place it to another place, and I select the Ninja simulation container, going to live generic. And so this is the basic simulation. Why is it interesting? Well, it is interesting because what we see here is the output material. We have a two-dimensional noise superimposed, added on top of this fluid swirl, and this two-dimensional noise is providing details. And that is fine, because we are still working with the two-dimensional simulation and adding two-dimensional details, so there is no performance cost. But still, if you have a look at the resulting volume, it is it's rich with these details added by the two-dimensional noise. I'm just moving this thing back to its original place. And so this is how the sim looks like without the 2D noise. This is how it looks with the 2D noise. How do we do this? I'm selecting the simulation container, and we have an already working regular way of providing volume smoke with data, and this is by external render targets. And here you could see that I could pick which internal render targets, which simulation buffers I would like to use as input for the volume smoke, and the only thing is that I have added the output. So until now we have been able to use pressure, divergence, velocity, density, and all these internal buffers, but from now on we could use the output buffer as well as input for the volume smoke. And comparing it to this container, which is stage 5B, it's the same thing. We are using a noise to make the whole thing more detailed, but it's a three-dimensional volumetric noise, and it is much more performance heavy compared to this two-dimensional detail noise. So it is important to know, and it's so many more things we could do by writing output to render targets. But we're gonna talk about this later on. Moving back to the change list, exposed base materials. Well, in this case, base material, I mean the core simulation materials. Many of you have been experimenting by reconfiguring these materials. Normally they are located in Fluid Ninja Live per core per Fluid Sim. And so you have been replacing these with your own versions, but it's a bit tedious. So what I have done is like I've exposed in the Ninja Live component per live generic, and it is on the very bottom, core sim materials. We have like an array with all the material instances, so you could put your own versions here and still you don't have to modify the blueprints. It's very good if you're experimenting with the modified version of base materials. Will be easier for you. And finally, a few minor features. Yeah, this one is handy. Until now, yeah, imagine this situation that we have this volumetric smoke container, and we have this we have the two-dimensional simulation, and normally they are both visible, which is very disturbing. We don't want the two-dimensional sim to be visible. And until now, we have solved this problem by simply adding a null material to the output material fields. But now I have added like a proper bool flag for it, output material invisible. If you check this, it is hiding the two-dimensional basic sim while keeping all the properties like collision detection and all that stuff. So it's very handy if you quickly would like to hide the original sim, like in the case of using volumetrics. What other things we have? Yeah, camera facing for volume smoke containers, examples how to attach volume smoke containers to characters. Shortly, that's it. Now, there is an important change I would like to mention. There is a dedicated chapter for it. It is chapter number 29. I'm happy how Ninja development went, and in my opinion we could stop adding features, and it's time to start exploring what we have. So in the next few months I would like to focus on producing new content. No features, but using the existing features and creating things like water and fire and smoke, and explain how you could use Ninja really. And I've been thinking a lot how to deliver this, and my idea is to use use cases as separate packages. Here is a new folder in the Ninja structure marked with this purple color. It is called use cases, and as you could see, it is a numbered folder. It's self-containing, so all assets have been dumped into this, and is like 2 megabytes if I zip it. And what I'm going to do is going Ninja Live Discord, and I'm going to publish all these packages using the community Discord, one by one, small packages, and you could download them and simply copy them to the Ninja Live project folder structure. And I've included the first example package, this water world thing, which is already like a use case example, to show you how it works. So it's really like a zip file, and you just unzip it and copy the content to the Fluid Ninja Live, and then you will have an example level and a few assets, and hopefully in a month or two we'll have like 100 of these use cases. And sounds complicated, but it's all explained here with the Discord link, which you could also find in the video description. So I encourage you to check back regularly and try to figure out what are the new use case packages. You could also do your own use case packages, and we will publish it via Discord. And the best packages will be included time by time every month to the Ninja core package, core project. Shortly, that's it. Thank you for your patience, and let us start use case development. See you next time.